Hi class, this is help with your homework assignment, page 23 and 24 out of your practice book. So we're going to go over problems 1 through 5. Before you start those problems, I want you to think about what we talked in class today with terminating decimals and repeating decimals. And I want you to think about rational and irrational numbers. Start by reading through this example that talks about how Erica wrote 1/3, so 1 divided by 3, and 2/3, 2 divided by 3. She got a repeating decimal here and a repeating decimal here. So, look through this example, pause the video, and then we'll continue. Okay. Alright, so let's go ahead and start with number 1 now that you've read through the example. I'm going to go ahead and scroll up a little bit here. Alright, so Erica says no matter how many decimal places she divides to, when she divides 1 by 3, the digit 3 in the quotient will keep repeating. Is she correct? Explain. So as she keeps dividing here, 1 divided by 3, 1 divided by 3, yes, she keeps going because each time she subtracts, she gets a 9. Okay? So think about that pattern that we looked at today with the 9s. Here's where those 9s come from. Okay? So what you would do in your explanation here, you would write something about that yes, she is correct. So yes, she is correct. And then I want you to explain why in your own words. So tell me about that, something like, yes, she's going to keep dividing by 3 each time. And 10 divided by 3 each time is going to give you 9 left over. So we're continually having that repeating decimal. Okay. Next is the decimal for 4 over 3, a repeating decimal. Explain. So a couple ways you can think about this. You could think 4 divided by 3. That's literally what that means, 4 divided by 3. So 3 goes into 4 once. Okay. We subtract, get a 1. It doesn't terminate here, so I'm going to drop another place value. So this is just some long division, if you're comfortable with that. 3 into 10. 3 goes into 10 3 times. 3 times 3 is 9. And we subtract and get 1. Doesn't terminate yet, so we drop another place value. This is similar to what's happening up here. So again, we're getting 3, and you're seeing a continual pattern of it's going to keep going. Okay. Some of you wanted to turn this into a mixed number maybe, so 1 and 1/3. And at this point in your math career, you probably remember that 1/3 is 3 repeating. So explain that depending on which way you were thinking about it. Okay, number 3. How could Erica have used the decimal that she wrote for 1/3 to find the decimal for 2/3? Well, if you look at 1/3 compared to 2/3, okay, so here's the difference between the two. Okay, so 1/3 I know is 0.3 repeating. Okay, we figured that part out. Well, if I have another 0.3 repeating, so I'm going to add another 0.3 or double that, well, 0.3 doubled is going to give you 0.6. Okay, so that would end up with 0.6 for 2/3 and 0.6 repeating. You could also go 2 divided by 3 if you're comfortable with division. And you'll see that 2 does not go in there. Okay. Add a place value. 3 goes into 20 6 times. You get 18. And then when you subtract, you're going to get a 2 again. Add another place value. So again, you're going to get that continual pattern of repeating 6s. Okay, let's go on to number 4. Okay, so here's number, oops, too far. Number 4 and 5. Sorry guys, there we go. Okay, so write the decimal for 1/8. Explain why this decimal is called terminating. So we know it's terminating based on what they're saying here. And we can explain why it's called that. So 1 divided by 8 is what that means. Okay, 8 will not go into 1, so I add a place value. 8 goes into 10 once. 1 times 8 is 8. Subtract, we get 2. 10 minus 8. Add another place value. I get 20. 8 goes into 20 twice. 2 times 8 gives 16. And when I subtract, I end up with 4. Add another place value. 8 goes into 45 times. And at that point, 8 times 5 gives you 40. I have nothing left over. So there's nothing left to divide out. It terminates or stops because I don't have to keep repeating anything. It terminates after that 5. Okay? So you would explain that based on your work here. Finally, tell whether each statement below is true or false. If it is false, write an example that proves the statement is false. All fractions can be written as repeating decimals. Okay, so this is false because here's an example. Here's 1/4. There's a fraction, but 1/4 is equal to, as a decimal, 2500, so 0.25. That does not repeat, so that one will be false. You'd write false, and then write F for false. Give me a reason why. So give me an example of your own. The next one, if a fraction can be written as a repeating decimal, only one digit can repeat over and over again. Well, we saw this in class, where multiple digits can repeat over and over again. Like if we had, here's one from class, 36 over 99. Well, the 3 and the 6 are repeating, so you get 0.36 repeating again and again and again. Okay, so that one is also false, and then give an example of why. Okay, hopefully this is helpful.